Reliability begins when done stops being a sentence and becomes a check. Today on Fluid Coding and AI, we are comparing one long-running agent task three ways: a normal Claude Code loop, a managed agent with an outcome rubric, and a managed agent that can delegate to subagents. The failure we care about is familiar. The agent says it finished, but the repo disagrees. Tests are still read, a required file is missing, the implementation drifted outside the request, or the final report sounds confident while the file system tells a different story. So this is not a model ranking, it is a harness comparison. What changes when the system around the model can define done, grade the result, retry, remember useful lessons, and split work across agents. Imagine the same feature request in all three runs. Add a project feature that touches the API, user interface, tests, and docs. Keep the code changes minimal. Add or update tests. Run typecheck, lint, and the test suite. Leave a short implementation report. Do not churn unrelated files. That task is long enough to expose agent failure, but concrete enough to verify. The question is not whether an agent can attempt it. The question is what stops it from declaring victory too early. The first run is the normal Claude Code loop. One agent reads the codebase, edits files, runs commands, fixes failures, and reports back. Anthropic's Claude Code docs frame this as an agentic coding environment that can inspect files, execute local commands, and work through problems with tools. The normal loop can already be powerful when the repo has clear checks. A good prompt can say, read first, make minimal changes, run tests, fix failures, and stop only when the checks pass. The fair baseline is not a raw prompt with no guardrails. Claude Code can use project instructions, skills, tests, and hooks. A stop hook can run checks when Claude tries to finish, block the stop if tests fail, and feed the failure reason back so the loop continues. That matters because it turns a local loop into a partial reliability harness. The agent is still in one main conversation, but the stopping condition can be tied to objective checks. The weakness is that the context keeps growing. Anthropic's best practices guidance notes that conversation, file reads, and command output fill the context window, and performance can degrade as that happens. Long tasks also accumulate false trails, noisy logs, and partial assumptions. The agent may still succeed. But when it stalls, stops early, or loses track of a requirement, the human often becomes the retry loop. That is the babysitting costs managed agents are trying to reduce. The second run moves the same task into Claude Managed Agents. Managed Agents launched in public beta on April 8, 2026, as a managed harness for cloud-hosted agents. The docs describe agents, environments, sessions, and events with built-in tools like Bash, file operations, web fetch, web search, and MCP servers. The important shift is that long-running work can live in a stateful session with sandboxing, scoped permissions, tracing, checkpoints, and hosted execution. Outcomes are the reliability idea in its cleanest form. Instead of only sending a task, the developer sends a defined outcome with a rubric and optional maximum iterations. The docs say the agent begins work when it receives that outcome and continues until it achieves the outcome or exhausts the iteration limit. The default maximum is 3 iterations and the cap is 20. During the loop, outcome evaluation events expose greater feedback, retries, and whether the outcome was reached. Anthropic reports that outcomes improved task success by up to 10 points over a standard prompting loop, with the largest gains on harder problems. For structured file generation, Anthropic also reports internal gains of 8.4% task success on docx and 10.1% on PowerPoint files. That is useful evidence, but it is scoped evidence. The public posts do not disclose the full task suite, model IDs, prompts, cost, latency, failure taxonomy, or exact grader setup. So the honest claim is narrower. Outcome rubrics appear to improve structured file generation reliability. Managed agents also add memory, and Anthropic later introduced streaming as a research preview. Memory is described as a file system-mounted layer where agents can save and manage memories across sessions. Dreaming is a scheduled process that reviews past sessions and memory stores, then curates useful patterns. This is promising, but it should not be treated as magic self-improvement. Persistent memory raises practical questions: what gets remembered, who can inspect it, how stale lessons are removed, and whether a bad lesson can keep steering future work. The third run keeps the outcome rubric, then adds multi-agent orchestration. In managed agents, one coordinator can delegate to other agents inside a single session. The docs say those agents share a container and file system, but each has its own persistent session thread and conversation history. That gives the coordinator a way to fan out independent work. One agent maps the codebase, another implements a scoped change, another updates tests, and another reviews the result against the rubric. Fan-out helps when the work is actually separable. Anthropic's Claude Code subagent guidance points to research-heavy work, multiple independent tasks, fresh perspective reviews, verification before committing, and pipeline patterns. Their rough signal is 10 or more files to explore, or 3 or more independent pieces of work. The same guidance warns against subagents for small tasks, tightly sequential tasks, same file edits, too many specialists, or work that needs constant peer-to-peer coordination. Parallel agents can save time, but they can also create merge conflicts and coordination overhead. The deeper lesson comes from agent evaluation. Anthropic's evaluation writing separates the agent's final message from the actual final environment state. For coding agents, deterministic graders are natural: run the code, run the tests, inspect the files. Model-based graders can check fuzzier things like completeness, format, and quality, but they are non-deterministic, cost more, and need calibration. The strongest harness combines both: objective tests where possible, rubric checks where needed, and traces that make failures inspectable. Here is the practical verdict. A normal Claude Code loop is strong when tests are clear, the task is scoped, and hooks prevent false completion. A managed agent with outcomes is stronger when done can be expressed as a concrete rubric and retry loop. A managed agent with subagents is useful when the task decomposes into independent research, implementation, testing, and review. But more structure is not automatically more reliability. It can add cost, latency, beta surface area, and coordination failure. The best setup is the smallest harness that makes the final state prove the claim. If this helped you think more clearly about coding agent reliability, like the video and subscribe to Fluid Coding and AI. The next step is simple. Stop trusting the final message by itself. Make the file system, tests, trace, and rubric prove that the work is done.